Hello and welcome. My name is Imad, and we are continuing with physical sciences, organic chemistry. So, in this session, what we're going to start looking at is an introduction to organic chemistry. So, right here on the first slide, I've got the following, right? Let's talk about what organic molecules are. Well, when we study organic chemistry, we are dealing with a branch of chemistry that deals with organic molecules, right? An organic molecule is a molecule in which it contains carbon atoms, right? So basically, a carbon-based molecule, that's an organic molecule or an organic compound. Now these molecules, they can range in size, they can be simple, or they can be complex. In other words, they can have really long chains and really fancy rings as well. Or they can have simple structures like 2, 3, and 4 carbons, but we will see in a moment why carbon is so unique. Now, although the main element in organic compounds is compound, we can sometimes have other elements as well. So as you can see over here, you can get elements like nitrogen, you can get elements like nitrogen bonded to it. There we got some nitrogen. Let's see if I can get an S over there. We got some nitrogen, right? Um, we can get nitrogen appended to it. We can get some sulfur appended to it as well. Even oxygen, hydrogen, and phosphorus. These are common things in these molecules. Now, what is not mentioned here is that also very common is sometimes you find that it is also bonded to the halogens like fluorine, and let me just write that down over there. Sometimes it's bonded to things like fluorine, chlorine, iodine, right, as well as bromine. So those are also some of the common ones that you may find attached to it. That deals with the halogens over there. Now, organic compounds, they make up a big part of our own bodies. They are in the food we eat, they are in the clothes that we wear. They're also used to make products such as our medicines, our plastics, our washing powders, our dyes, and the list goes on. So if you check your textbook, whatever textbook you're using, I'm sure if you page the organic molecules or organic chemistry section, you'll find some detailed information of what other uses organic compounds have. So as a basic introduction, you need to know an organic molecule is one that contains carbon. These are molecules that range in size. They can be really simple or they can be complex, and sometimes we commonly find they're bonded to hydrogen, oxygen, nitrogen, as well as the halogens. And also organic compounds are found almost everywhere with many uses. Right, so let's move to the next slide. Let's just get the let's get the cursor going. Right, and let's clean that away. Right, so the main source, let's talk about the source of carbon. Where do these carbon atoms come from to give us our organic molecules? So over there you can see that the main source of carbon is actually carbon dioxide in the air, right? Carbon dioxide in the air. So how do plants convert carbon dioxide into organic compounds? They do it through a process where they absorb and they convert sunlight, and this process is called photosynthesis. Animals, they feed on the plants, and that is how they gain the organic compounds that they need to survive. And another important source is fossil fuels, right? And we'll speak a little bit more about this later, such as coal, petroleum, and natural gas. Right. So there we've covered two things. We spoke about carbon. Organic compounds are carbon-based molecules that are often bonded to other atoms like hydrogen, nitrogen, sulfur, and also the halogens, group 7 molecules. Group 7 atoms. And we also mentioned that the chains can be simple or they can be really complex, and we'll see why in a moment. And then we've discussed the sources of carbon, carbon dioxide, how plants get it, how animals feed off the plants, and also where they are found in fossil fuels. Right, let's get a new sheet going, and let's just select the cursor. Right, so why is carbon unique? Now, there's a few things about carbon that we should note, and I'll write them down here. What should we know about carbon? Well, carbon is a group 4 atom. So if you go to the periodic table, you'll find that carbon is group 4, right? And what does this mean? It's got a valence electron structure where it's got 4 valence electrons, right? This thing has got 4 valence electrons. In fact, it's written over there. It's got 4 valence electrons, right? Which means that each carbon atom can form bonds with 4 other atoms. That makes it really, really special. And I know I'm underlining this and you're seeing a lot of red on the screen, but you got to see this, right? So it can form bonds with 4 other atoms. So if you look at carbon, the idea is that carbon can have 4 covalent bonds, right? Like so. Okay, and because of this, it can actually form long, unique chain structures. Okay, I'm just going to make the color there blue. It can form long chain structures. Now, these are two things I will discuss shortly. They can be branched or they can be unbranched, and they can also become very, very complex due to the number of bonds they can form. So let's quickly mention something. Because carbon can have four bonds, what we can say there is that carbon can have a single bond with itself, it can have a double bond with itself, or it can even have a triple bond with itself, right? And then, of course, each carbon atom must have a bond like so, bonded to something else or another carbon, or whatever the case may be. But at the end of the day, these carbon atoms must have 4 lines around them. Each of these lines represents a covalent bond. Let's just write that a little bit neater. A covalent bond. Right. Okay, let's see what's next. We'll talk about branched and unbranched compounds.